So to graph this system, you can start off by making a graph of this inequality. So you can start off by pretending it's a little equation. So to get an idea of what an equation is going to look like when graphed, you can make an x and y table to get some data points for where the graph is going to cross. And then this is where you'll just want to plug in points carefully. If you plug in a 1 in there, 2 times 1 makes 2, 2 plus 4 makes 6, absolute value of 6 is 6, 6 minus 2 is 4. So 1 comma 4 is going to be a dot on this graph, right there. And then you can find some other dots by just going through the table and getting some more values. So I saved the pain of watching me plug all these in. I plugged in 0 and I got out 2. I plugged in -1, I got out 0. So we can use these data points and graph them. And then we'll have the first, the structure of the inequality graph, the line at least for it. So there, we'll stop there. We've graphed the top one. Now let's do the same thing with the bottom one. So do the same thing, start off as an equation. You can make an x and y table for this one too if you wanted, but this is actually one where you could put it in slope-intercept form, y equals mx plus b, if you remember that, to help you graph the line. But if we want to stick with a data table, we can do that. If I plug in a 0 in here, I've got 3y equals 15. It means y needs to be 5 in order to make that be true. If I plug in a -3, I have to do a little bit of arithmetic. I'd have to add 3 to both sides to get 3y equals 18. Divide by 3 and you get 6 there. If I plug in a +3, I got to subtract 3 from both sides to get 12. 3y equals 12. Y is 4. And this one isn't an absolute value equation, so this is just a straight line because it's linear. Everything's to the first power, and they're not touching each other. So I got enough data points. I'll plot these. So there's a sketch of the line that goes through there. So now what we can do is, now that we have the lines, actually, a big note here, this should be a dotted line because it doesn't have the or equal to symbol. This is a solid line. This one should be dotted here in red. Okay, that's better. So now that we have graphs, now we can find out where to shade, because when you're graphing inequalities, there's a two-dimensional area that represents all the possible solutions. And let's start with this one up here, this green one. And it says y is greater than or equal to all this stuff. To find out where our shading is going to be, we're just focusing on the green line right now. It's either going to be inside the V or outside the V. And you find that out by plugging in a test point. Plug in -2, 0. If you plug in -2 in here for x and 0 in for y, the left side is 0. The right side simplifies to be -2 when you plug in -2 in here, because that's -4. -4 plus 4 is 0. Absolute value of 0 is 0, and 0 minus 2 gives you -2. So is 0 greater than or equal to -2? It is indeed. So that means we shade going this way. And I'm not going to shade over this line yet, because maybe I'm going to find out I'm supposed to shade below for this next one. So we'll wait. But the green line shading goes all the way up. You do the same thing for this one. You pick a test point and just see if it works. So for this red dotted line that I have here, you can pick any point you want on this side or on this side. And 0, 0 is a nice and easy point to test, because if this turns out true, then all this stuff below the red line turns out to be true. So if you plug in 0 in here for x, and if you plug in 0 in for y, you get 0 is less than 15. That's a true statement. So the red solution is everything below the red line. So the total solution is where the two shades meet, right here, where the green and the red are shaded. So in your answer, if you're doing a test or a quiz or something like that, the only place you want to shade is where both the areas meet, right here.